nanoparticle at 50% loading gives 35% higher tensile modulus while providing meaningful gamma attenuation for troops at high altitude, or in CBRN scenario, which is the last discussion in any war game, that is a CBRN or NBC. So that is also one domain where we should start thinking upon. A dual function material that no current BPJ addresses at this stage. STF liquid armor is also one field where a lot of work is happening around in the world. A nanosilica suspension in ethylene glycol impregnated into textile flows freely normally, solidifies when the ballistic impact happens. 30% nanosilica loading gives 54.75% more energy absorption. These figures in the green, yellow and blue are the energy absorbed values. Operational significance. You can put STF everywhere. A rigid plate cannot go. Collar, groin, deltoid joints, etc. This is the engineering answer to the Ukraine coverage lesson that I brought out. Nature solved a version of this problem million years ago. Let me show what it found. Nature has been running an armor research program to 500 million years. And the question is whether we are intelligent enough to copy it. Fish scale architecture, overlapping silicon carbide plus organoplastic composites, scale on a grooved base, and the FE validation has already taken place. The capability it unlocks are flexible, conformal, multi-hit protection for shoulder, sides, and abdominal areas where rigid SAPI plates cannot go. Additive manufacturing we have already covered a lot into the earlier sessions. But there is a requirement that was also brought out by one of the panelists in earlier sessions, that we have to have the logistic revolution in additive manufacturing. The traditional ceramic armor is manufactured centrally, shifted to forward areas or transferred to forward areas of operation, and when damaged is irreplaceable in the field. Additive manufacturing changes this entirely. Silicon carbide, alumina, and boron carbide are now printable. The operational Sindoor lesson is direct. Emergency procurement takes months. A core level or maybe at the command level, additive manufacturing facility producing replacement SAPI plates insert on demand eliminates that dependency. Multi-domain dividend. One investment in advanced composite material pays across 4 domains simultaneously. The graphene reinforced polymer for a BPJ backing is same material which is used for UAV frames, where one of the industries is working, which I came to know. The ceramic composite for WAP vehicle armor is the base for naval hull base. So this is the argument for a dedicated armored forces material research center, which is precisely what the CME can do. Let me now connect for all of this what India has already built. We have gone a long way. India's indigenous armor story is not a story of absence. It is a story of delayed acceleration, and the acceleration is now visibly imminent or underway. ABHED. This ABHED stands for Advanced Ballistic for High Energy Defeat. Boron carbide ceramic plus polymer matrix developed at the DRDO Industry Academia Center of Excellence at IIT Delhi. Weight is 8.2 to 9.5 kg for different BIS levels within GSQR limit. Modular design, front, rear, and additional panels. TOT23 Indian Industries. This is no longer a laboratory result. It is transitioning to a manufacturing reality. Kanchan. Kanchan was from DMRL and India's answer to Cobham British architecture. Ceramic tiles sandwiched between composite panels and RHA. In service since 2004, Mark 1 Alpha adds ERA to the frontal arc. 118 of them has already been ordered. Indigenous content up to 41 to 54%. And beyond Arjun, the future MBT program post 2030 is already in engineering with AI integrated, active protection, and ceramic ERA hybrid configuration. SMPP and BIS ecosystem. And it is very heartening to know that we have developed our BIS for all these protection systems. In 2009, a declared requirement of 3.5 lakh BPJ and zero procurement. By 218, the first Make in India contract was placed. By 2024, Abhed is ready. By 2025, post-op Sindoor, emergency contract are issued. IS 17051 of 2018 means the now define our requirement and threat levels, licensing rather than licensing the same to American NIJ standards. Several countries have already approached India for supply of these BJP jackets. The direction of travel is unmistakable. But who actually manufactures? And now we have seen a few of the industries here. Let me show you the industrial spine of our country. Rana Kali was one of the program where the combined, which has proven the combat scenario. Titanium alloy plus ceramic plus polymer, designed for Lancer helicopter and Mi-17 1V. Protection against 7.62 mm ball and AP, 12.7 mm AP. This armor has received and withstood actual attack in service. That is not a trials result, that is a combat endorsement. Technology transfer to Midhani, the light combat helicopter variant is in development. WAP 8x8, the newest milestone. November 2025, technology transfer to NTB International Pune and QMI covers the CUMI, covers the entire manufacturing chain, zirconia toughened aluminium sandwiched with rubber and metallic backing. Staneg 4569 level 2 and 3, defeat 14.5 mm AP rounds and RPGs, 300 unique ceramic panels per vehicle. Production has commenced, and this is not a future program, it is a production reality. Jackal is a DMRL. The DMRL, I would say, is the material spine of India's armor program. And 3 decades of R&D, over 40,000 tons of armor produced. The transfer model that Jackal Steel to SAIL and Midhani is a successful model that has now embraced WAP ceramic armor to NTB and QMI and Abhed to 3 Indian industries, as I already brought out. The strategic gap, there's still a gap which has already been discussed, but few of them is like, first I would like to flag is the scale of requirement, as already brought out, that is the declared requirement of 10 lakh BPJ, against which only 2.5 lakh has been supplied till now. And the emergency procurement kind of procedure post Operation Sindoor, what we took, is a symptom, not a cure. The cure is a sustained domestic production surge anchored to a clear specification and a funded program pipeline. Second gap is the multi-hit ceramic limitation. Although BIS 6 level of Abhed do have it, but that is for the plate. We do not have for all-round protection. So that multi-hit limitation still do exist. The thermal extremities, what I brought out from Siachen to Thar, is that 90-degree operational envelope of temperature is yet to be breached, and where this is where we can collaborate with the industry, academia, and DRDO with CME. CBRN multifunctional, because we are the joint training services for the CBRN, and we tend to forget about this scenario. Once it will happen, then God only knows. So we have to have our protection system to be tested against CBRN scenario, which is not taking place. So this SCRI stands for Sarvatra Center for Research and Innovation, where I had this small nucleus of research and innovation at a core of engineers in College of Military Engineering. And we have moved a lot way since last 4 years. It was established in 2021. There was a lull period in this COVID. Post that we have accelerated a lot of things. And one of them is Padam Kavach. This is boot anti-mine engineers. We have been talking about the body armor, but the foot is the one where foot on ground has to be there for any kind of success in operation. So, and that foot is having danger from those mines, enemy mines. And boot anti-mine is one. So it was a composite work at SCRI, composite sole, which attenuates 99% of the initial explosive energy from an anti-personnel ND Mark 1. Correction, NMM14. Commercially produced by Artisans and is now available in 3 variants. So that is the kind of success we could get through in this. Another one is Sarvatra Kavach, which has been delivered. It is a full body armor suit. And it was, in fact, initiative of one of the Army officer, Major Anup Mishra. Now, the suit is being manufactured by TESL, that is Tata Advanced Systems Limited, and a lot of field formations are giving their orders to that. So that is the second success story, which is in fact 50% lighter and 50% cheaper than the global equivalents. Boot anti-mine testing facility, like one area where I was discussing one of the DRDO scientists now, this domain of boot anti-mine, mine boot I'll call it henceforth, is where no testing facility exists. TBRL has one, and the only one exists with us, that is at CME. Now, over the period, what I've seen that since last 3 years, I've been testing a lot of boots of the formations. And there has been a drastic improvement in their quality by doing those results. And we could have achieved this quality now. Around 37,000 has been placed by one of the command recently. And we could have achieved this earlier had there been a testing facility of this kind, because from this kind of test, they improve their design and they come up with better solutions. Like even including a additional Kevlar layer would increase the efficacy of that boot. There are other active research threads what we are undertaking, waste valorization using steel swap, EMI shielding in inbuilt infrastructure in the concrete, that is one protection, and thermal composites and foldable composite joints, for out of which we have been able to make one foldable recce board, 3-man recce board. And third one is like we are collaborating with a lot of research academia and industries, and that triad is the solution to all the problems now. So I'll just wind up by saying that research gaps and what way forward we should have is one, multi-hit ceramic architecture that we should have for all body all-round protection.